Hello, children. Welcome to Right Tuition Classes. We are doing Physics Numericals Revision Lecture number 3. Okay. Now, look here. Just before I go ahead with this numerical, I would like to clear your concepts. Okay. Remember, children, a resistance of a wire R. Do you know what is the resistance of a wire? I'm not going to tell you what is resistance now. Okay. I'm going to assume what is the resistance of a wire. The resistance of a wire is directly proportional to length of the wire. The resistance of the wire is directly proportional to length of the wire. The resistance of the wire is inversely proportional to area of cross section. So when I compare both of them, resistance is directly proportional to length, inversely proportional to area of cross section. So what is R equal? Rho into L upon A. R is equal to rho into L upon A. L stands for length. Rho stands for specific resistance of the material of the wire. And A stands for area of cross section. Here, rho becomes a constant. Okay. I repeat this, children. Remember, resistance of wire is directly proportional to length of the wire. I mean, greater the length, greater the resistance. Smaller the length, smaller the resistance. Area is resistance of wire is inversely proportional to area of cross section. Thicker, जितना ज्यादा thicker, उतना कम resistance. जितना ज्यादा thinner, उतना ज्यादा resistance. Okay, inversely proportional में उल्टा होता है. So when I combine them, resistance is directly proportional to length and inversely proportional to area. Now, when I remove this proportional sign, children, R is equal to rho is a constant of proportionality. Right now, I say into length upon A. But this rho is nothing but specific resistance of the material of the wire. Specific resistance of the material of the wire. Okay. Now, the sums of this type are getting here are based on this formula. Okay. So remember that, children. We go ahead now. Let's try to understand. Okay. The metal wire of resistance 6 ohm. There is a metal wire of resistance 6 ohm. Is stretched so that its length increased. Length is increased to twice to the original length. Length is increased to twice. Length is increased to twice increased to twice. Length is increased to twice to the original length. Okay. Now calculate the new resistance of the wire. Length, when the length increases, naturally this resistance is going to increase. They want you to find the new resistance. So what I do, please have a look at this sum. Children, very simple sum, but short. In your exam, you can expect a question of this type. Okay. So right now, see what I do. Suppose original length of the wire. Original length of the wire. Let me take it as L1. Okay. Original length of the wire is L1. Okay. And please have a look here. And area of thickness. Please have a look here. Area of thickness is or area of cross section of the wire original. I'll call it as original area of cross section of the wire is A1. Got it? So resistance R is equal to rho into L1 upon A. But what is this L1 upon A1? Now, please have a look here, children. This, what happens is, remember, L1 is, we don't know L1, okay? We don't know L1, children. L1 is only they said the original resistance is 6 ohm. Got it? So therefore, 6 is equal to rho into L1 upon A1, and I call it as equation 1. Okay, now listen here, what they are saying. The length is, the wire is stretched. The wire is stretched so that its length is increased twice to the original length. The wire is stretched. The wire is stretched. Therefore, its new length is twice the original length. well, it becomes 2L. So naturally, since the wire is stretched, length is doubled. Okay, new length is doubled. Therefore, area of cross section, it is going to become thinner, children, and it is inversely proportional. The area of cross section becomes half. Are you getting me? Area of cross section becomes half. Length becomes double, so area of cross section becomes half. Are you getting me? Half of A1. So what it will be? Half of A1. Area of cross section is half of A1. Okay. So now listen here. Therefore, new resistance, they want the new resistance. So how can I get my new resistance, children? So you can clearly see here, children, therefore new resistance should be equal to rho as it is into the original length, the new length. Okay, what is the new length? Twice L1 upon what it is, this twice half A1. Okay, new area. Okay, so new resistance is rho into 2L1 into divided by reciprocal 2 upon A1. So it becomes 2 2s are 4, 4 times rho into L1 upon A1. But what is it? Rho into L1 upon A1, you can see it, children, that is 6. So it becomes 4 into 6. Can I say from 1? And what will happen, children? Please have a look here. So naturally, this is becoming 24 ohms. So what is the new resistance, children? New resistance is 21 ohms. Got it? Little writing, please have a look here. I hope people will understand me here. Little writing became little difficult. I don't know why, because my hands become stiff. I don't know why. Okay. So I'll just say new resistance. Okay, your new resistance is, so naturally rho into length. What is the new length? 2L1. Okay. And what is the area of cross section? Half of A1. New area of cross section. Okay. So now when you try to simplify it, you get 24 ohms. Okay, children. Quite a simple sum, children. We move on to the next question. How much heat energy is question number 2? How much heat energy is released when 5 grams of water at 20 degrees Celsius changes to ice at 0 degrees Celsius? मतलब how much heat energy is given up? Release मतलब बाहर गया. When 5 grams of ice, 5 grams of water at 20 degrees Celsius, you have 5 grams of water, children. Okay, how much? What is the mass of water? 5 grams. Okay, 5 grams of water at 20 degrees Celsius. It is initial temperature is 20 degrees Celsius. Initial temperature is 20 degrees Celsius. I'm just writing information here. Okay, and specific capacity of water, C, C of W is how much, children? 4.2 joules per gram degree Celsius. Okay, and specific latent rate of fusion of ice, L, is how much, children? 336 joules per gram degree Celsius. Okay, I want people to know this. Okay, this is per degree Celsius. नहीं आएगा इसके लिए बेटा. I'm sorry. Per gram. Okay. Now all are going to pay attention here. See, I'll tell you, it's such a simple sum, children. Initially, you have water. And what is this water? Its temperature is 20 degrees Celsius. A pani ka temperature 20 degrees Celsius. This initial temperature, water, okay, what is water it is? Okay, its initial temperature is 20 degrees Celsius. Now this water, you're going to start cooling it. Okay, it's cooling. Cooling means heat is being released, heat is being given out. So this water will keep on losing energy, temperature keeps on falling. I mean, it keeps on losing heat energy, and ultimately it will come to, please have a look here, it comes to water at 0 degrees Celsius. Water at 0 degrees Celsius. Okay, it comes to water at 0 degrees Celsius. Now, water का please have a look here. कोई भी देखो, it will be water only. Okay, क्योंकि cool कर रहा है 0 डिग्री सेल्सियस. अभी पानी को हम 0 डिग्री सेल्सियस से और कूल करेंगे तो क्या बन जाएगा बेटा? आइस बन जाएगा बेटा. आइस बन जाएगा और वो 0 डिग्री सेल्सियस ही रहेगा पहला. और इसको और भी ठंडा करेंगे it will remain ice, the temperature can further fall. But here, when you look at it, I is at zero, they are said. You have water, 5 gram of water at 5 gram of water at 20 degrees Celsius. This you started cooling it, withdrawing heat, releasing heat from it. It went on falling. The temperature of water became 0 degrees Celsius. The water mass remains the same 5 gram. But एक बार ये पानी का टेम्परेचर जीरो हो गया, अब ये पानी और कम होगा तो पानी रहेगा ही नहीं. So it gets converted into ice. Okay, it will get converted into 5 gram of ice at 0 degrees Celsius. See here, water, no change of state has taken place. Water था, खाली change fall in temperature है. So इधर क्या हो गया? That is an delta T. Got it? That is that heat is given out. Okay, heat given out, but no change of state. So this heat is given out. So heat given out, suppose this is Q1, Q1 will be given by MC delta T. Okay. And here, water to ice, a change of state has taken place. Whenever change of state has taken place, children, here you have to use latent heat of fusion. Okay. So I'll just say Q1 is what? Q1, heat released by water at 20 degrees Celsius to achieve 0 degrees Celsius is equal to M into C of water into delta T. Mass is how much, children? I told you 5 gram. And what is C of water? Oh, this mass is in 5 gram, and this, of course, mass is 4.2 joules per gram. It is gram only, 4.2 joules, okay, per gram. Into fall in temperature from 20, it has come to 0. So 20 minus 0 is 20. So when I do it, it becomes 5 twos are 10. So 420 joules I'll get. When I multiply, I'll get 420 joules. Now listen, again, heat released by water at 0 degrees Celsius to change to ice at 0 degrees Celsius. So don't agree, change of state has taken place, so it should be M into L. M is 20 gram and L is, again, when you look at it, 336 joules per gram, so it should be 336. Got it? So how much you get? 0, 2, 6 are 12, 1, 7, okay, 2, 3 are 6. Got it? 6272, 6720 joules, okay? So total heat released will be equal to, children, total heat released will be Q1 plus Q2. Q1 was only 420 joules, but ये तो 6720 है, तो दोनों का ऐड करूंगा 40. 7 plus 4, 11. 7,140 joules. Okay, this is the answer of this question. A very simple question, children. We move on to the third question now. A uniform wooden beam may be 80 centimeter long and having a length of 250, weight of 250 GF, is supported on a wedge 10 centimeter from end A. Calculate the maximum weight that can be placed at A without causing beam to tilt. Draw the diagram of the arrangement. So I've drawn this beam AB. Can you see here a beam AB? This is end A. You can see my pen here, end A, cursor here, and this is end B. Got it? The weight of the and 80 is length of this beam is 80 centimeter. It is uniform. Am I right? When they use the word uniform, you should understand the whole weight of the wooden beam is at its center. Now, since it's 40 centimeter long, the center of the beam will be at 40 centimeter. Since it's 80 centimeter long, the center will be at 40 centimeter mark. That means the whole weight of the scale is at 40 centimeter mark. So it is 250 G. Now, what they want me to calculate, the maximum weight that can be placed at A. So naturally, see here, what will happen, since the weight is at 40 centimeter mark, it will get tilted. It will get easily tilted on this end towards this end B. So what happens, we have to put some weight at A so that it can balance it. So the maximum weight we can put to balance it, we have to say that, okay? So right now I say let it be X gram. Now this anti-clockwise, this is bringing out, please have a look here. This is bringing out, when you look at it, children, clockwise movement and anti-clockwise movement, okay? When you look at it, this is your clockwise movement and this is your anti-clockwise movement, okay? This is anti-clockwise movement. So by law of movements, anti-clockwise movements, anti-clockwise movement will be equal to clockwise movement. Now, please try to understand, how do you get this anti-clockwise movement and clockwise movement? Movement of force is force into distance. So what is this weight? That is xg. Got it? X into, what is its distance from the fulcrum? Fulcrum is 10 centimeter mark. So this is at, please have a look here. This is 10 centimeter, I'll say. Okay, is equal to this 250 into, what is its distance? This is at 40 centimeter mark. This is at 40 centimeter mark. So distance of this from the fulcrum will be 40 minus 10, 30 centimeter. So this is 30. So what will happen? X is equal to 250 into 30, the whole thing upon 10. 10 one time, 10 three times. So X is equal to, this should be 750 gram. Are you getting me here? So it's naturally, children, 750 GF should be placed. Therefore, 750 GF weight should be placed, should be placed at end A, to balance the beam, Okay, children? It's a very simple sum, okay? People don't read it. Just read see the length of the question and think it's difficult. It's something very simple, okay? We go to the next sum, children. Now, this question number 4, a very simple one, children. You have to diagram alongside shows the pulley arrangement. Can you see this? Now, I'm going to use this also for the solution. I'm not going to draw it once again, children. I want to use it for the solution also, okay? The same diagram. So I have to draw a diagram alongside shows the pulley arrangement, copy the diagram and mark the direction of force due to tension on the mobile pulleys. Now look here, children. Suppose there is one luggage bag, okay? This luggage bag, if a person tries to carry it by this handle here, got it? Suppose it is weighing 20 kgs. Now what will happen? Suppose he tries to, two people lift it. Now the same luggage bag, two people lift it, okay? Same luggage bag, two people lift it. One from here, one from here. Two different persons are lifting it, okay? So what will happen when one person was lifting it, the total weight was 20 kgs, okay? kgf. Now what will happen if two people lift it, then each person will apply a force of 10 kgf to lift it. So 10 kgf, 10 kgf, 20 kgf gets lifted. Are you getting me here? So the same logic applies here. Got it? So remember, this weight, please here, this movable pulley, this movable pulley is balanced by, you can see it, children, two ropes, okay? Can you see this? Two strings, okay? Two strings. It's balanced by two strings. So both the strings, they experience a force, tension, okay? They experience a tension. So that force of tension, I'll take it as T and T here. I hope you're understanding me here. Got it? Then children, this is your T in upward direction. Okay, the force of tension is experienced in a upward direction. Okay, children. Now this E will also be equal to T. Now the next part, B part. What is the purpose of the fixed pulley? So the solution, okay, this solution starts from here. This diagram also I told you children was the diagram of A part as the answer. Okay. Now B part answer. They're saying copy. What is the purpose of fixed pulley? The fixed pulley, the fixed pulley changes the direction of applied efforts. You see, because of the fixed pulley, you have to apply an effort in a downward direction. If this fixed pulley would have been not there, you'll have to apply an effort in an upward direction. Got it? Whereas applying effort in a downward direction is more convenient. Are you getting me here? Hence, the fixed pulley changes the direction of the applied effort. Now, C part. Children, you can see here. If the tension is T newtons, deduce the relation between tension and, please have a look at, deduce the relation between tension and E, effort, okay? So look here, children. Tension is E is equal to, please here. I want people to pay attention here. Okay. T part, if tension is T newtons, deduce a relation between T and E. It should not be T and E, it should be L and E. Deduce a relation between L and E. I better correction, okay? Somewhere I saw, I mean, even in the paper from where I took, it was T and E. I should be L and E. Here, this L is balanced by 2T. Two tension, okay, are balancing this total load, okay? Whereas effort is equal to 1T. That means, therefore, please have a look at L is equal to twice effort, or effort is equal to L upon E. Okay? L upon 2, sorry. Effort is equal to L upon 2. L upon 2. Okay, this is a relation between it. Calculate the velocity ratio of the arrangement. Got it? Since, please have a look at children. If the load moves up by a distance x, okay, that means each of this have moved up by a distance x by 2, x by 2. Are you getting me here? X and x. Okay? I repeat, children. Just sorry. If the load moves up by distance, x, then each of the strings, the two strings balancing the movable pulley, have to move up by a distance xx. Got it? They have to move up by a distance xx. That means this end, this string, will loosen up by a distance 2x. That means effort moves by a distance 2x. Okay? So what will happen, children? See here, I repeat, if, please have a look here. The load moves up, if the load moves up by a distance x, then the effort moves up, okay, effort moves down by a distance, means if the, sorry, I should write like this. If displacement of a load is by a distance x, displacement of the load is by distance x, then displacement of effort will be 2x. Now, why 2x, children? This here, the load moves up by distance x. The two strings, they move up by a distance x. That means this string will loosen up and this effort has to move down by a distance 2x. Got it? Now, velocity ratio is displacement of effort upon displacement of load. So this will be 2x upon x. So how much you get? 2. So velocity ratio will be 2. Velocity ratio will be 2. Then comes, please have a look at E part, okay? Now this E, now answer of E, children, please have a look at this. What is this? Assuming the efficiency to be 100%, what is a mechanical advantage? Mechanical advantage is L upon E. Mechanical advantage is L upon E. If L is, please have a look here. If L is 2T, effort is 1T. So naturally, mechanical advantage is 2. Yeah, F part of the question is calculate the effort E. Calculate the effort E. Calculate the effort E. So what is L given to you in the picture? You can see here 1000 Newton. So naturally, they see here MA is L upon E. Again, I use the formula of M upon MA equal L upon E. Now MA is how much? Therefore, E I want. Okay. And MA is how much, children? MA is 2. 2 is equal to L is 1000 upon E. So what is E equal? 1000 upon 2. How much it will be? E equal 500 newtons. E will be 500 newtons. Okay. And last part of the question is state the factors that reduce the efficiency of the arrangement. State the factors that reduce the efficiency of the arrangement. Now, state the factors that reduce the efficiency of the arrangement. Arrangement means we are talking about, not in general, children, please have a look here. Efficiency, why a machine can never be 100% efficient, you know, children, because of a part of the input energy always gets used up in moving the different parts of the machines. Second, always a part of the input energy gets used up in overcoming the forces of friction. Forces of friction. But here, children, I want, please have the same thing. Of course, it's a different way they're giving us. Okay. State I'm doing the G part of the answer. I want the G part. Okay. So here the G part, how we're going to answer with respect to this arrangement. Okay. State the factors that reduce the efficiency of an arrangement. See, efficiency is reduced because a part of the input energy is always used up in moving the various parts of the machine. Also, the input energy is used up in moving against the force of overcoming the force of friction between the moving parts. Whereas here, the state the factor that reduce the efficiency of this arrangement. Okay, so I'll tell you factors that reduce the efficiency of the arrangement are: one, the string used is not exactly elastic. There is a force of friction. There is a force of friction between the string and the police. And lastly, I'll say the weight of the mobile pulley. Weight of the mobile pulley. It's not weightless. Exactly, it cannot be weightless. Mobile pulley. The weight of the mobile pulley. The weight of the mobile pulley. So I just said it, children, with respect to this arrangement. Okay, children? We go to the next question now. A ball of mass 200 gram. What is ball of mass? 200 gram. Okay. Is thrown vertically upwards with the initial velocity u equal 30 meter per second. Now, such that it attains maximum height in 3 seconds. And question is, A part of the question, What is the potential energy of the ball at the highest point? Potential energy is given by the formula mgh. So here when you look at it, children, I know the value of M, I can say 200 gram. I know the value of G, children. G will be, 10 meter, 9.8 meter per second because I not mentioned it. We're going to take, and H, H is been not said. So I think I'm going to do, see, at V equal 0 at maximum height. Okay. Now, I'll say H V square equal U square. No, T is given. Okay, which is a formula. Please have a look here. Which is a formula where T comes. The three equations of motions are there, children. So three equations of motion where I want H. So naturally, what is that? H is equal to UT plus half AT square, GT square. Okay. So H is equal to U is 30 into time is 3 seconds plus half into 9.8 into 3 into 3. This is 4.9. Okay. So 90 plus 9 8s are 72. 9 4s are 36.43.2. So when I add this 133.2 meter. Now potential energy U is equal to mgh. M is 200 gram को 1000 में convert किया into 9.8 and H is 133.2. So 2 zeros, got it? And then you multiply 2 into 9.8, 19.6 into 133.2, the whole thing upon 100. So when you multiply 19.6 into 133 point, how much it is? 2. So what you get, you can see here, children, what answer you get when you multiply 19.6 into 133.2, you get, children, 2610.72, the whole thing upon 100. So how much it will become? 26.10. That is 1072. So can I say 26.11? Okay, joules. Now what is the next question asked, children? The B part, this is the A part of it, okay? U is a potential energy. Now B is a kinetic energy, children. Kinetic energy equal half mv square. Kinetic energy equal, I should say, by law of conservation of energy, kinetic energy is equal to potential energy at top. What is potential energy at top? 26.1111 joules. Okay, we get it, children.